Mrs. Often, and this video will introduce you to dilations in the coordinate plane. Dilations in the coordinate plane are the one type of transformation that we will study in this unit, which is not an isometry. That is, dilations in the coordinate plane do not preserve the size of the figure. They produce a figure that is similar to, but not congruent to, the original figure. Let's get started. At the end of this slide deck video, you will be able to dilate, that is, reduce or enlarge a figure in the coordinate plane when the center of dilation is the origin, when the center of dilation is another point, and you will also be able to determine the scale factor given a dilated figure. To be successful with dilations in the coordinate plane, we will work with vectors that are drawn from the center of dilation to the vertices. It is important to remember that every dilation has a scale factor, referred to as K. If K has an absolute value between 0 and 1, it is a reduction. If the absolute value of K is greater than 1, it is an enlargement. Obviously, if K is equal to 1 or 0, we don't have anything very exciting going on. When K is 1, the figure remains unchanged. When K is 0, we just get a point. So dilating with the origin as the center, we can see here that our figure ABC has been set up. We're going to dilate this figure, and triangle ABC will be dilated about the origin, 0, 0. We see that vectors have been drawn to A, to B, and to C, and then to an ending figure. We can do this by starting out drawing our vectors going from the origin to each of the vertices. Vector A will go to 2, 3 in its component form. The vector for B is 2, 1 in the component form, and the vector for C is 4, 2 in the component form. I'm going to dilate this according to the rule, or according to a scale factor of 2. So what I'll do is I'll take all of these vectors, multiply them by my scale factor of 2, and I will regraph them. You see them regraphed here in blue. So my new vector for B goes to 4, 2. My new vector for A goes to 2, 6. I'm sorry, I mislabeled A previously. That was at 1, 3, not 2, 3, as I had stated. And my vector for C is going to go over here to 8, 6. You'll notice that all of the vectors for the image, the green triangle, pass through their corresponding vertices on the pre-image, the black triangle. Now, because I've dilated with the origin as the center, my values for A prime, B prime, and C prime are actually just going to be the vectors changed into coordinates. So those are the coordinates of the image. So a quick summary of this. We're going to draw vectors from the origin to the vertices of the figure, and because we're going from the origin, the vectors will, in component form, have the same coordinates as the original vertices. Multiply each of these vectors by the scale factor, K, and use the vectors to locate the new coordinates of the image. So we see this in action. Here's ABC, original vectors, and then our new vectors. So let's look at what's happening in these other pictures. Well, here, triangle ABC, our pre-image, looks like it's gotten smaller. In this case, we have a scale factor that is between 0 and 1. If we look at this, I can compare my vector drawn to the pre-image from the center of rotation at the origin. And that looks like it's at 1, 0.5. And my vector for B, my image or my pre-image vector, looks like it goes from, it has a component form of 2, 1. If I compare these, comparing the image and pre-image in that order in a ratio, I will discover that my value for K is 1/2. Moving on, I see this other one. Notice that my orientation has changed here. B has flipped over to here. A has gone to A prime at this location, and C has gone to C prime at this location. Because that orientation has changed, and because my image is larger than my pre-image, that to me indicates that we have a negative scale factor, and also that that scale factor has an absolute value that is greater than 1. I can determine this scale factor by comparing the relative size of my vectors. So my vector in component form here for B, once again, 2, 1. My vector to B prime, I'll do this one in red, is -4, -2. If I compare those in a ratio, I get -4 over +2. My scale factor is -2. And that is what's causing this triangle both to be flipped in its orientation and to be larger. All right, let's look at another example. This time, the center of dilation is not located at the origin. In this case, vectors are going to be extremely helpful if we are given a center of dilation that is not at the origin. By using vectors, we can think of that center of dilation as being the origin, and we can plot points for our image relative to the center of dilation using the idea of vectors. So let's go ahead and see this in action. All right, so here's our first step. Now, my center of dilation is located here at 1, at -1, 2. And I'm going to start by drawing these vectors. Now, each block in this is equal to 0.5. So my first vector from the center to A is going to be 2, 1. My vector from the center of dilation to B is going to be 3, -1. And my third vector from the center of dilation to C is going to be 1, 2, 3, 4, 5, 1. Written all those vectors in component form. Now, all I need to do is to take this, each vector, and multiply by whatever my scale factor is. Then I can act as though my center of dilation is the origin and use that as a set of directions to plot the vertices for my image. Here, I've multiplied. My scale factor for this figure is 2. So you can see I've multiplied these and gotten my larger vectors. And then I go ahead and I plot my new figure with my new vectors. Instead of 2, 1, I have 4, 2. So A prime is going over 4 and up 2 from -1, 2. So that is going to be at 3, 4. I'll be going over 1. Instead of going right 3 and down 1, I'll be going right 6 and down 2 for my new vector. That puts B prime at 5, -4. Sorry, 5, 0. And finally, instead of going right 5 and up 1, I'll be going right 10 and up 2 for my center of dilation. And that puts C prime at 9, 4. So that's how I can dilate when the center is not the origin. Okay, finally, to find the scale factor and center of dilation, I'm going to draw all of my vectors passing through the coordinates of the image and pre-image vertex. We can divide a side length from the image by a corresponding side length from the pre-image. We can see here, this is pretty easy to do. H prime E prime divided by HE is 3/2 or 1.5. As you can see, I'm drawing vectors from the vertices of the image through the corresponding vertices of the pre-image, and the center is the origin. All of these vectors are intersecting at the origin. So my center of dilation is the origin. Now, the other way to find that scale factor, as I noted before, was that I could have taken my vector lengths and divided them by each other. It is going to be vector to the image divided by the vector to the pre-image, dividing those components, and that will give me this same scale factor. I hope this video has been useful to you on dilations using both the center as origin and any point as origin. Lola and I wish you a great afternoon.